Okay, so U and V are events, and I've got these facts, and I want to figure this out. So let's start by writing down what we've got. So union V, oops, let me make the union, kind of looks like a V there, doesn't it? So it's going to be the probability of U plus the probability of V, subtract off the probability of U and V. Okay, so probability of U I know is going to be 1 minus 0.3. This is 0.6. Okay, so now I want to start thinking about this. So I see what I have here, and I see this. Okay, so just because you know, well, like we just did here, so probability of U complement, right, was 1 minus probability of U, right? So I'm going to do that same thing with this. So I'm going to say this is going to be the same thing, or if I did it the other way, equal 1 minus probability of U complement, right? Okay, so do that same thing here. So this is going to be 1 minus the probability of U intersect V complement. Okay, so now let's go do De Morgan's on this, right? So let's fix this up a little bit. Keep the negative sign out there. So then here, this turns into probability of U complement union V complement. Okay, this I was given, right? So between these two, I get 0.13. I meant to write that. Well, actually, I'm just going to leave it there. I'm just going to leave it as it is. So I get minus 1, and then this is 0.4, right? Oops, not a minus in there. This minus is out here. Okay, so 1 minus 0.4, so that's a 0.6. So 0.6, and then this gives me a 0.6 in here, so it's a minus 0.6. Oh, look at that. Didn't need to add those things together at all. They're right there. All right, so let's talk about tossing things in the air. So there's different events. When I toss a coin in the air, the outcome of the first toss does not affect the outcome of the second toss, right? So that's going to be A and B. And the same thing with A complement, it's 1 minus probability of A. Okay, so what's the probability of getting 2 tails? I want a tail and a tail, so that's going to be 0.3 times 0.3, because that's what it says. So what's the probability of getting 1 tail? So there's options. I could get a head and a tail, or I could get a tail and a head, right? So if I get a head first, that's 0.7, then the 0.3, or I could get the 0.3 and then the 0.7. Okay, so what's the probability of getting no tails? No tails, that would be getting 2 heads, right? 2 heads, so that would be 0.7 squared. So what's the probability of getting at most 1 tail? Okay, so remember, at most, we want to be clever, right? I think. Or you could go through and say at most 1 tail, that means head, head, or head, tail, or tail, head, right? And you could go figure that out. Or 1 minus no tails. I like doing this. So 1 minus no tails with the 2 tosses would be 0.3 squared. And it would give you the same thing if you did this way too. All right, so I'm going to let you do these for the Zoom.